So this is the second part of battery backups. I thought I would do a couple of things. A couple of things that I hadn't intended on doing initially, which was looking at this after the new battery was put in. This has since run for a couple of days. Anyways, let's take this thing apart. First thing, making sure it's unplugged. And just like before, I'm going to flip it over and pull this battery connector out. So let's get this cover off. And let's take a look inside after a couple of days. And I don't see any change to our little goop here. So the battery's out now. Let's get these cables out and kind of walk through what is going on. This circuit board just slides out. So let me get these connectors disconnected. That's coming off of there. And I think the ones on the bottom are for the battery. And what else do we got? We got two more connectors. Does this one got a locking tab on it, or is it just kind of? It does. Oh, and our ground lug. There's a protective earth right on that. That might be pretty well staked in there. I don't think I need to take it out completely. Let's get this board out. And there's a little spring tab. Oh, that's for the button. Okay. So a single-sided board. All of the through-hole stuff is on the flip side, and all our surface mount stuff is on this side. Do I have all the connections removed? The battery's connected. All right, I think that should make it pretty much be free. Oh, that's a nice-looking board. So let's walk through what happens before everything comes into the board. Just to clarify, let's just make sure our capacitors are discharged. This is power coming in. A longer screwdriver. X cap. This should all be discharged. The discharge resistor I thought I saw. Coming in from the wall, let me move the board out of the way for a second. And let's just look at the bottom of this case. Coming in from the... This is kind of a messy business here. All right, so hopefully you can see this somewhat well. So we got the power cord coming in from the wall here. The unit claims it has RFI and EMI suppression. How do they achieve that? Well, they use a bunch of ferrites. So here's, well, it's basically in a common mode choke arrangement. So here, line and neutral is coming in and is wrapped around this ferrite core. So that provides suppression between line and neutral. But what about line and earth and neutral and earth? So I think what they do, so there's line and neutral, but then line to earth and neutral to earth. How are they doing that? I see the earth going up to the connector. Oh, okay. So they just do line and neutral, which is fine. That's just any kind of common mode noise on line and neutral is what you want to be suppressing anyways. And then the earth is also suppressed, but the earth wire runs up to the surge only ports. There's two ports on this side. Hopefully that can be seen. There's two ports on this side, and then all of the battery powered ports are on this side, the outlets. So this one here runs up to the surge only. And there's, oh, I think there's another one. What is that one? Let's see if we can get a flashlight in there and see if we can see a little more clearly what's going on. Can this be seen pretty well? This might. The problem is that it's just all black plastic, so it's really hard to get contrast here. Power and neutral come in off the wall. They come in through here. Line comes through this circuit breaker right here. And then line comes back out again and then goes in through this connector to the board. So the neutral then comes through here and comes to this connector. So that's line and neutral. And this other connector, the second connector, is what's coming out. That's not it. There's two connectors here. There's two connectors. This is the one that's just going out to surge. So this is the surge side, and this is the battery side. So this is going into the board, onto the board, and specifically, it is going to the location here, and then it comes back out for just the surge protection section of the board, which is just the two outlets. And then the rest of the circuitry handles a bunch of different things, which we'll get to. The battery backup outputs are powered here. So I think that takes care of all of the connections. And this connector over here is for the battery protected outlets. That just leaves a few other little things here. One is this battery connector, which is just basically an inline series connector that comes from actually on the negative side of the battery. It's through the negative terminal of the battery through to the board where it's sleeved and shielded, but then goes right into the board. Not via connectors, but actually it's just directly soldered through it's through the board, so that's better than just sitting on top of the board. But okay, that's all of the enclosure and connection points inside the battery backup. Let's look now at the actual board itself, because that'll tell us more about what's going on. Quite a bit on this board, but you kind of can break it down into some blocks. A lot of interesting stuff here. We have some filtering. Right off the line, we have an X cap, big nice X2 cap. So that's across the line and neutral. That helps again with filtering and noise suppression. And then there are 3 pretty hefty looking MOVs. They're kind of close to each other. I don't know why they were so close like that, but there's I'm wondering why one is different than the other two. I think the 2 of these that are going, there's one between line and neutral, and that might be a beefier one. And then there's line earth, neutral earth. Pretty sure. Let's look at the back. We're just going to flip to the back here, take a quick peek. As we look, see here are the MOVs right here. And we have one going line to neutral, because this is our line trace coming in this way. Neutral, making sure I'm actually not talking crap. Neutral's on top, sorry. Neutral's on top, and line is over here. We've got discharge resistors in the back here to discharge that X cap, so I don't get, you don't get zapped either by the plug or poking around inside here. A metal oxide varistor on the line to neutral path, but also equally important, earth is here. Earth is here. Is there a track on the other side or like a link? How are they getting it to? Typically, you're going to have one connection, one MOV between line and neutral, because if you have a surge on either the line or neutral side, at some point that voltage goes too high, this clamps and then sinks that current back to the other leg. So either line to neutral, neutral to line. The other 2 are for protection to protective earth. I would imagine though, if these did fail and they failed short, it would pop the circuit breaker that's on the unit itself. So that's probably, maybe they don't need to have thermal protection on them because of that, but still these can get kind of really hot and cranky when they reach end of life. On the back side here, there's the 2 connections, and there's a 3rd connection right next to it. Oh, I think that's the gas discharge tube. It is. Cool. So, to earth, there is line to earth, line to earth and neutral to earth. And then there's a gas discharge tube right here, and it terminates across to earth. So it's typically in this gas discharge tube, which is connected between the earth pin, the pins that are going on each MOV that is going to earth, then goes through a gas discharge tube before it is connected to the earth pin here. And what the gas discharge tube does is that there's like a lightning strike in the vicinity, or there are pretty intense voltage surges to earth, then the MOVs will collapse, and then the gas discharge tube, if they can't absorb all that voltage, then the gas discharge tube also will intervene, and there'll be a breakdown, a controlled breakdown here to pass that current to earth. Also, I think perhaps it allows them to get away with less beefy MOVs, because if these were to fail short, then the gas discharge tube would still provide some protection. Further down the line, we have our earth terminal here that goes back to protective earth, to protective earth. These are Y capacitors, which are coupling, I think, between line and earth again. Let's flip to take a peek. And one of these goes to, here's our neutral again, and it comes to here, and then it goes a little tiny trace, 2 resistors, and then here's the Y capacitor across there. there's another Y capacitor that is here to here with no bleeder resistor? I guess not. Oh, maybe it's here. Maybe they, no, because that's going to some kind of sensing or something. Anyways, they can be used for isolation, but here I think they're using it for more noise suppression between line and neutral and earth. Then there's an inrush limiting NTC, and that's probably being used for the power supply so that when the whole thing first turns on, there's not a whole bunch of current rushing in to start up the switch mode power supply, which we'll get to in a moment. So I think there's one here. It looks like, yeah, it looks like there's one for, there's at least two of them. There's one here and there's one here. I think one of the NTCs might be used for what I believe in the center here is our H bridge, which we'll get to in a second. I don't want to jump ahead. So what we've got over here is two relays. When this thing goes into battery backup mode, then there needs to be isolation from the outlet. So this disconnects from this whole thing when the battery backup turns on. As soon as it turns on, these things will click either out or in to open both line and neutral. And if we look on the back side, we can confirm that by seeing here's our line, our neutral track coming this way. There's that one relays tab, and here's our line coming this way, and here's the other relays tab. And it actually has two tabs. So when it switches across, it switches across to here, and this one switches across to here. And then I don't think they're particular. I don't think they're isolated because everything is inside a box, and the only thing you have accessibility to is the little button, and that button's behind plastic. So this is just mains referenced switching, probably through some sort of bootstrap thing that is powered up past the relays to allow something to power, to let a little bit of current in. And I do see that actually, you can see here, there's a little track, here's the line side, comes past here, this is where the relay is at, and here's where it's switching across and switching across. And there's two diodes here, and it runs off to, well, one of these I think is coming from Earth. So yeah, one of these I believe is actually, if it doesn't find an, oh, okay, so one of these might actually be interesting. One of these Y caps, I believe, also has a little tap off of it here to provide a signal to the Earth not present indicator. It looks like, I'm not really sure how they got this biased, but it's just an LED and a link that goes to something over here. It starts to get a little bit hairy, but something over here is providing power to this LED should there not be a ground detected. There's something here with a kind of an initial buck, like a bootstrapping to get this whole thing started up. And then once this is started up, it will, I'm pretty sure what it does is once this is on, once this is the off, this, I'm almost positive this is the off the line switcher. So you have, it has some kind of bootstrap coming past from the input to power it up. And I'm thinking perhaps this chain of resistors might be what's, you see all these resistors here in a row, and there's a pin. Actually, what's the pin there? Another X cap, is it? Is that an opto isolator? This is an optical isolator here. This, I believe, which has the pin right there, two pins. Might be this inductor? I think it's the inductor. Something in here is bootstrapping to get this started, and then once it's powered on, then the whole push mode power supply will come on, and I'm pretty sure once that comes on, then 12 volts is available, and then this is it doesn't say what the coil voltage is. 15 amps 125, 12 amps 277, 50. So these are definitely carrying the whole current. And I think it's even got three, it's actually got a little bit of belt and suspenders here. There's these two relays here that provide this connection so that you have line and neutral disconnected. So if you touch the plug, you don't get zapped by this thing generating its own 120 volt AC power supply. And then this, I believe, switches the battery in, or it switches the output. This might switch the output between AC and the battery. That's my guess with this one, without going crazy into, complete reverse engineering. So let's go back. We're going to kind of go past over to here. It seems to me like this supports bringing these online. And you'll hear it when we power it on, kind of the order of operations, where you'll hear 2 relays click on after like a second of things kind of powering up, and then this powers on. So it might be also a microcontroller that this supply comes online because it's all through the bootstrap. That brings this online, 12 volts comes up, microcontroller comes on, and then it's responsible for turning them on so that that might make sense. Either of those could possibly be it. This over here, roughly, is where the internal power supply is. It's got a switch mode, a pulse transformer, with a pretty beefy FET for switching what's needed on board. The next piece to the left of it is primarily the output driving circuitry for battery backups. If it goes into battery backup mode, where the main supply is gone, then there might be 2 stages here. I'm familiar with the H-bridge stage. This provides the stepped sine wave. This is not a pure sine wave output. The topology for a pure sine wave is it's similar, not the same, but similar. The next thing down the line here, just to kind of keep the party going, is that you've got some kind of, the battery power is coming in here. Here's positive 12 volts and then negative. And maybe this is the first stage to switch the battery DC side across this transformer in order to be able to get a voltage on the secondary side. So this particular transformer is a step up transformer. So we got 12 volts coming in, and we want to get about 120 volts coming out. So we got a turns ratio of about 10 to 1, maybe a little bit more because of funkiness with it not being a pure sine wave and losses through the windings and losses through all the circuitry. So it might be a different turns ratio, but this looks like 200 volts. So I think there's a combination. It looks like there's a feedback winding that's being tied together there. And then our main pins on the transformer, it may have many. Oh, it's got a bunch of pins. This could be really, yeah, there's 6 pins coming out of there, but they're paired together. So you've got one coming off, going this way to this terminal, to this MOSFET. This one, which looks like it might be a sense or something. No, but it's high power. It's got a bunch of exposed traces on it for heat dissipation. Then this other one here, which isn't really, it's connected through something. Oh, through the fuse. Looks like it's through this 40 amp fuse. Interesting. So we flip to the back and we're looking at ICs and integrated components on the back. This might be for some sort of communication, like isolated communication, because it's up near the top where there's, yeah, it looks like this might be used for programming and communication, because there's ground, reset, VREF tools, and there's another header here for RX and TX, which is depopulated, and it's right in the vicinity of this IC. Down below here, I think this is the main microcontroller, and then down here, I'm wondering if this is some kind of dedicated control chip for driving the battery backup functionality, because I don't think you'd want to be doing that through software unless you really have, or firmware unless you really really wanted to do your own thing. And then there's some optical isolators here, which I think are for the feedback. They're right near the output stages, so I'm wondering if that's to detect what the voltage is, to be able to feedback and control driving functionality, to make sure that the voltage and frequency are being properly matched. I would imagine there's probably one for the line and one for the neutral side. But that's my guess. This is my guess on kind of what I think is going on with this board. It's pretty impressive. And the other interesting thing too is it does have some intelligence in it, either the microcontroller or the dedicated chip that we saw in the back, to sync line frequency. So if you have 60 hertz, you're generating 60 hertz here. When you switch between these two, you can't just randomly switch within less than a half of a cycle. You know, you don't want like two peaks of the sine wave, one right after the other. That ain't good for anything. This has a separate kind of it has sensing to be able to sync the frequency of the sine wave so that when it generates the modified sine wave, it's in sync with what was the original frequency. And I just noticed this little polyester film cap sitting here, and I'm wondering if this is perhaps our drop cap supply. I don't want to push that around too much. To bootstrap this thing on startup. I have to look at that in more detail. I caught my eye, and I hadn't mentioned it before. Other little things: 40 amp fuse for the battery. When it's going full bore, it's going to be 20 amps, 25 amps. So this is just to make sure that it decisively, if there's a failure and the battery shorts or whatever, or something shorts, it'll pop this fuse. Because when it's disconnected from AC, the circuit breaker isn't going to do anything because that's coming from main. So you need something for the battery as well. But the battery is a limited supply to begin with. Even if it's fully charged, it only has so much energy in it. A little beeper, it makes beeping sounds. And then I guess the user interface. I forgot about the user interface. How could I forget about that? A button, a spring, which may be related to this button. I'm thinking it perhaps is. There's a button here for the various modes, turning it on, turning it off, all that stuff. And then changing this voltage sensitivity, things like that. The LED that's red and green, and then it gives you your various colors, blinking, all the other status indications through a single little LED. So this board just slides back in. It has to go this way. All right, so as a treat for making it all the way through this video, I wanted to show just how much current the battery really does pull when it is in a discharge mode when there's a power outage. So I'm plugging in the battery back up into AC power right now. Actually, you can tell that it's turned on because it is charging the battery, and it's negative 450 milliamps going into the battery, and you can see the battery voltage climbing. So even though there's no relays clicking at all, you heard nothing click when I plugged it in, there is at least circuitry that is going past and charging the battery up. 13.37 volts at 450 milliamps, about 6.5 watts. And so now I'm going to power it on, and we'll hear the relays come on, or it will explode because I didn't put it back together correctly. Let's find out what happens here. So we're going to power it on while it's still powered on to mains AC. I got to hold it down. A little nervous. One relay comes on, and then those two come on at the same time. And what is going on? Oh. Okay, cool. So what we saw happen there freaked me out for a second. Oh my goodness. Oh geez. Okay, let's turn it off. Now it's completely off. You can hear, I don't know if you can picking up on my microphone, but you can hear those relays go off and on as a pair. There's two relays clicking on, off and on. And when this thing turns on, I think the first thing it's doing is detecting if there's a battery actually there. Otherwise, it'll go in, it'll beep and go crazy, telling you there's no battery in the system. So the first thing it did is it came on and was powering the load. It actually, with the thing actually plugged into AC, the first thing it's doing is testing to make sure that it's actually able to run the battery backup circuitry when you first power it on. It was like a power on self-test, basically, which is nice. We'll kind of walk through it again, just seeing what's going on here. So powering it on, the first thing it's going to do, power on that first relay. I think powers up all the electronics, and then both relays will click, or not. Maybe it doesn't do it every single time. Maybe it knows there's a battery there because I disconnected it before and something got cleared or whatever, because it's not doing it this time. Interesting. Anyways, I've got a load plugged in. This load is actually presently at 110 watts. I will get a picture of it to show. And that's at about 0.56 power factor, 0.55. That's at 120 volts. I don't know why I'm saying 120 volts, doesn't really matter. But now it's on, it's powered by mains, and I'm going to disconnect the mains, and we're going to see, this should run maybe for 2 minutes, maybe 3. Actually, according to, let's see, let's put it in the calculator that APC gives us. That's right here. There it is. I might just put it in the, so we're going to put 110 watts. And it's saying it's going to run for 13 minutes, 8 seconds? No way. 110? 110 watts. 13 minutes, 8 seconds, it says. There's no way it's going to run that long because this battery's not that good and it's not fully charged. It might run for a couple of minutes. We'll just see what it does, but you'll see that current and voltage. So I'll stop yapping. You can see that it is charging the battery. So like the battery voltage is still climbing. The float voltage on this, I think, is somewhere between 14.4 to 15 volts. So this is still way below what it would consider to be fully charging, and then just like trickle charging once it was fully charged. I'm gonna keep a little stopwatch going and we will see how long it runs. I don't think it's gonna be that long, but here we go. Disconnecting from mains, and we'll see what we got here. Start, go, disconnecting. So the voltage is falling very quickly. You can see that the current is going up. So something is managing that output voltage to keep it at 120 volts. It's hanging on 13 amps through the battery. That's why these terminals, when we were securing them in the previous video, I was saying how important it was to terminate them. And we'll see that much current flowing through it. But let's see what our temperatures are. It's not beeping yet, saying that it's at very low voltage. And the voltage on the battery is actually okay. I'd say once we hit about 10.5 volts, it's probably going to start complaining. But let's look at the positive side here. Pretty cool, actually. 74, 76, not too bad. Now it's beeping, telling me that it's at pretty low battery capacitor rating. Again, this battery hasn't been charged for very long since the last time I tested it, so I'm not expecting it to go more than maybe another minute or so. We are at 1:40, but 13 amps coming off of there. So the battery is supplying 12 volts at 13 amps, so going into the system, 12 volts times 13 amps is 156 watts to output 110. So not particular, 108 right now. So not particularly efficient. It's about 60% efficient. This whole thing, where like a pure sine wave inverter, at least the one that I've got, is reportedly about 88 to 90% efficient. Then again, you're not running this continuously all the time. It's just for when you run, your power goes out. The battery seems to be doing a pretty good job. I think once these batteries get a good full charge in them, they'll run a lot longer. Coming up on 3 minutes. What was APC telling us that we're going to get? 13 minutes. Yeah, we're not going to get anywhere close to 13 minutes. And you can see that current continuing to climb. We're going up to 13.6 amps. I doubt it'll go over 20 amps because that would be about half the voltage it is now. I think once we hit 10.5, it's going to kick off. But you can see how much current is being pulled through that battery. It's pretty amazing. And the load's consistent. It's not like it's varying up and down. This battery, the battery it's trying to charge is very low. It's just hanging in there at 108 to 110 watts, up to 14 amps. And the voltage has fallen faster now, as you might expect, and I think it's probably going to cut out pretty shortly here. This may be a little bit cranky right now and may not be complete. See, you can see it bouncing around. I'm just going to quickly disconnect this. Maybe get it back in there. I just want to see if the noise. I can feel the heat coming off those MOSFET switchers at the top. They're definitely active when this thing is in discharge mode, and that's where a lot of the heat is coming off of. At 5 minutes now. So we're getting closer. That's it, cut out. Now you'll notice what happens is it's not completely out. So the outputs are off now, but the control circuitry is still on. And I think it's trying to stay active in case power comes back on. Then it would power everything back on again automatically, but I think it says something like 32 seconds afterwards. There we go. It's like 32 seconds after it cuts out completely. So I think it'll shut off the outputs and wait a little bit of time to see if power comes back on, to see if it'll just power all the outputs back on again. But otherwise, it will not. It will just stay off. And now my voltmeters, the meters are complaining about things. So, wow, lots of stuff covered in this video. Hopefully you found this video helpful understanding battery backups a little bit better. And there's things that I missed, or there's things you wanted me to go in more detail on. Happy to keep learning and to keep on digging into these things. If you like this video, please give it a thumbs up, like and subscribe. That's it for now. Thanks for watching, and I will see you in the next one. Take care.